For example 41, we're told that y is equal to e to the x cos 2x, and we're to find d2y by dx squared. So y is equal to e to the x cos 2x, and this is a product differentiation. So we have to apply the product rule. So dy by dx, we're going to leave the first, e to the x, differentiate the second. When you differentiate cos, you get minus sign. So this is minus sine 2x. Then we have to multiply by the differential of the inside function, which is 2. All right. So that's leave the first, differentiate the second, plus differentiate the first, e to the x, leave the second, cos 2x. All right. So dy by dx would be equal to minus 2 e to the x sine 2x plus e to the x, the cosine of 2x. So let's differentiate again. d2y by dx squared, 2 e to the x sine 2x is product. So it's minus, minus, and then we differentiate. If we want, we can take out the 2, minus 2, and then differentiate. We get, when we differentiate e to the x sine 2x, leave the first, e to the x, differentiate the second, we differentiate sine, we're going to get cos. So this is cos 2x multiplied by the differential of the inside function, which is 2, plus, plus leave the first, sorry, differentiate the first, e to the x, leave the second, sine 2x. Then we have to differentiate e to the x. We have to differentiate e to the x cos 2x again, but we did it already. See it here? E to the x cos 2x is actually y, and we did differentiate y already. So if I differentiate it again, I'm going to get minus 2 e to the x sine 2x plus e to the x cos 2x. All right, so let's simplify. This is minus 2 e to the x cos 2x. Sorry, not minus 2, this is 4, because there's a 4 here. So this is minus 4 e to the x cos 2x. This is minus 2 e to the x sine 2x minus 2 e to the x sine 2x plus e to the x cosine 2x. All right, this is 4 and this is minus 3. So it looks to me like this is minus 3 e to the x cos 2x minus 4 e to the x sine 2x. That's why I would have gotten, or that's what I got. I'm pausing the video. All right, so example 42 says, given that y is equal to e to the x cos 2x plus sine 2x, show that d2y by dx squared minus 2dy by dx plus 5y is equal to 0. So we have y is equal to e to the x, the cosine of 2x plus the sine of 2x. So This is a product. It's a function in x multiplied by another function in x. So I'm going to apply the product rule, which essentially says that if y is equal to u v, where u and v are products of x, are functions in x, dy by dx would be equal to u dv by dx plus v du by dx. So let us differentiate. So dy by dx, we are going to leave the first, which is e to the x, and differentiate the second. Differentiating the second means differentiating whatever is in the bracket. Differentiate cos, I get minus sine, so this is minus sine 2x, and I have to multiply by the differential of the inside function, which is 2, plus, if I differentiate sine, I get cos x, and I have to multiply by the different cos 2x, cos 2x, and I have to multiply by the differential of the inside function, which is 2. All right, so that's leave the first, differentiate the second, plus differentiate the first, which is e to the x, leave the second, which is the cosine of 2x plus the sine of 2x. All right, I guess if I want, I could probably simplify this. This might make my life easier if I simplify this. So if I simplify this, I'm going to get minus 2e to the x sine 2x plus 2e to the x cosine of 2x plus e to the x cosine 2x plus e to the x sine 2x. So let's simplify by grouping like terms. You have 2, you have 1, so that's minus. So this is minus e to the x sine 2x, and this is plus 3 e to the x cosine 2x. All right, if I want, I could factor out e to the x and treat it again like a product. If I want, I could factor out minus e to the x and treat it again like a product. So if I wanted to, let's just say I factor out minus, I don't have to do that, but let's do it. Minus e to the x. Inside the bracket, I'm going to have sine 2x minus 3 cosine of 2x. And now I'm going to differentiate to get the second derivative. So d2y by dx squared, product again. So leave the first, minus e to the x, differentiate the second, differentiate sine to get cos. So this is 2 cos 2x. And the 2 at the front is simply coming from the fact that I have to multiply by the differential of the inside function. All right, and this is minus 6, minus 6, minus 3, differentiate cos, you get what? You get minus sine 2x, and then we have to multiply by the differential of the inside function, which is 2. All right, so that is us leaving the first and differentiate the second. Plus differentiate the first. When you differentiate e to the x, you get e to the x. So this is minus e to the x. Leave the second. The sine of 2x minus 3, the cosine of 2x. So let's simplify to make life easier for ourselves. This is minus 2e to the x cos 2x, and negative times, and well, these are three negatives. So this is negative, this is 6e to the x minus 6e to the x sine 2x minus e to the x sine 2x plus 3e to the x cosine of 2x. All right, so let's group all of the sine and the cos together. This is 3 and this is 2. So this is e to the x. This is minus 6, minus 1, minus 7. So this is e to the x, the cosine of 2x minus 7 e to the x sine 2x. I hope I did not make an error somewhere, because in all of this, it might be difficult to find it. So what we want next is d2y by dx squared minus 2dy by dx plus 5y. So it's d2y by dx squared minus 2 dy by dx plus 5y would be equal to, so this would be equal to e to the x, the cosine of 2x minus 7e to the x, the sine of 2x, that's dy by dx, minus 2. Now dy by dx is this here. So this is minus e to the x minus e to the x, and inside the bracket I have sine 2x minus 3 cos 2x plus 5y, so that's plus 5y, but y is e 5y, which is e to the x, and inside the bracket I have what? Cos 2x plus sine 2x. Cos 2x plus sine 2x. All right, so let us simplify. We have e to the x cosine of 2x minus 7 e to the x sine 2x. A negative times a negative give me a positive, plus 2 e to the x sine 2x. A negative times a negative is a positive. All right, there's actually three negatives here, so I have to be careful. Three negatives, 1, 2, 3. 2 3s are 6. So this is negative 6 e to the x cosine 2x plus 5 e to the x cosine 2x plus 5 e to the x e to the x, and this is sine 2x. Now all we have to do is group everybody. So this is e to the x cos 2x Find the next one of that. Sine minus 6 e to the x cos 2x. Find another one. Plus 5 e to the x cos 2x. Is that 0? Yep, look like 0. Then now let's go to the sine. Minus 7 e to the x sine 2x plus 2 e to the x sine 2x, and lastly plus 5 e to the x sine 2x. All right. So in a sense, if you apply care, the cos e to the x cos 2x, those come out to 0, and the signs also come out to 0. The entire thing is equal to 0.